Today we are going to be looking at base 2. What is the difference between base 2 and base 10? What do they have in common? Why do we use base 2 for computers? First, let's take a look at base 10. We start with a 0, we add 1. Then we add another one for 2. Add another one, 3, 4, 5, 6, 7, 8, 9. Houston, we have a problem. We have no way in base 10 to be able to represent the number 10. What do? Well, we take a look at the top. We bring down the 0 from the top, put it down all the way to the bottom. Do you remember the old mnemonic that your grade school teacher might have taught you? 9 plus 1 equals 0, carry the 1. That's what we're doing. And then we go 1 plus invisible 0 equals 1. So we now have 10. Add 1 to it, 11, 12, all the way up to 19. Houston, we have another problem. We have no way of being able to represent the number 20 in base 10. So we go back up to the top, pull the 0 back down. 1 plus 1 equals 2, so now we've got 20. Now we can go ahead and continue all the way down until we get to 99. Where once again we've got a problem. So what do? The same thing. 9 plus 1 equals 0, carry the 1. 9 plus 1 equals 0, carry the 1. 1 plus the invisible 0 equals 1, and now we have 100. Simple. Matter of fact, this is so simple that you have been doing it since you were in elementary school. This is not rocket science. This is pretty simple. As a matter of fact, there are even some infants that have this comprehension and know how to do this. So let's talk about base 2 and computers. It's simple. Lights off, lights on, off, on, power off, power on. That's all there is to it. One bit, one state, whether it's on or off, is called a bit. 8 bits equals a byte. So whether it's a 1 or a 0, that's 1 bit. Now, let's go ahead and do counting in base 2. Start with 0, add 1. 0 plus 1 is 1. Simple so far. Houston, we have another problem. We have no way in just an on-off numbering system to be able to represent the character 2. So what do? We do the same thing that we did before. We go up and we grab the 0, we bring it down. 1 plus 1 equals 0, carry the 1. The invisible 0 plus the 1 equals 1. Oh, my favorite saying. There are 2 kinds of people in the world. Those who understand binary and those who don't. So at any rate, 0 plus 1 is 1. 1 plus nothing is 1. So there we've got 11, which is 3. 1 plus 1 equals 0. Carry the 1. 1 plus 1 equals 0. Carry the 1. The invisible 0 plus the 1 equals 1. 0 plus 1 is 1. Don't have any more numbers to add, so there's a 0 and my 1, and that's 5. 6. 1 plus 1 equals 0. Carry the 1. 1 plus the 0 is 1. Piece of cake. We're done. Bring down the 1. That's 6. 7. 0 plus 1 is 1. We have no more characters to bring down at all, so just bring them down. 1, 1. So 7 is 1, 1, 1. 8. Oh, the long number. 1 plus 1 equals 0. Carry the 1. 1 plus 1 equals 0. Carry the 1. 1 plus 1 equals 0. Carry the 1. 1 plus the invisible 0 equals 1. Awesome, we're set. So what we have here then is what you can see is that 2 equals the 1, 0, 4 equals the 1, 0, 0, 8 equals the 1, 0, 0, 0. Each unique bit doubles the value of the previous bit. So 1 doubles to 2, 2 doubles to 4, 4 the next bit becomes 8, 8 the next bit 16, 16 the next bit 32, so on and so forth. Now let's go ahead and create a sense of the order of the bits. Where there is nothing behind it, we have a viable digit. Actually, we start with 1 because there's nothing behind it. That's my first bit. 2, there's nothing behind the first bit. That's my second bit. 4, There's nothing behind that initial third digit of number 1, so that's my third bit. 8, there's my fourth bit. We are now going to count each of the 8 bits. And as we do this, we're going to show each bit represented by a 0 underneath. Above it, we're going to show each of the base 10 values of each of those bits so that you can see the comparison between the two. Here we go. 1, 2, 4, 8, 16, 32, 64, and 128. That's 8 bits. 8 bits is a byte. And that is basic binary numbering and the basic starting point that we use to work with computers. We now have the basic building blocks for what we need. Here, we will then go ahead and learn how to manipulate these numbers so that we can go ahead and use them in ways that we understand. And that will be the next lesson. I am Anthony Ford, MSIT, and I have been your digital guide.